Video, the solutions for the formative investing borrowing test for Year 11 General Maths. Question 1. Calculate interest earned on 10 grand borrowed over 2 years at 3.5%. It doesn't say what kind of interest, so I'm just going to assume simple interest. Obviously, the test is going to say specifically, so simple interest is SI is equal to PRT. The principal was 10 grand times by the rate as a decimal, 0.035, times by the time in years, which is 2. 10 grand times by 0.035 times by 2. That comes to $700 interest earned. 2. Edward deposits $12,400 in account, paying. So highlight what's important, 12,400, 4.5, 4.5. How long would it take to earn 3,000? So you've been told it's simple interest is important too. You've been told it's simple interest, so SI is equal to PRT. I know that he deposited 12,400, so the principal was 12,400. The interest rate was 4.5%, so 0.045. It's asking how long, so I don't know what T is, and it earned 3,000 in interest. So I can work out what 12,400 times by 0.045 is. 558 times by T. What is 558 doing to T? It's timesing, so the opposite of that is dividing by 558. And that will cancel out to give you T. T is going to be 3,000 divided by 558, which is 5.376. So I'll round it to 5.38 to 2 decimal points. It doesn't say what units it needs to be, so 5.38 years. Russ invested $1,800 over 18 months and received 1941.75 in total. What simple interest rate did Russ's investment return? So this is tricky because you're given the total. You're not told the interest. So it's important we know 1,800. It's important that we know it's 18 months. It's important that you had 1941.75 in total. But remember, total is equal to the principal plus the interest. So the total was 1941.75, and we put in $1,800 plus interest. Interest is going to be $141.75. That's how much interest was earned on top of the investment. And now I can use SI is equal to PRT because the interest earned was $141.75. I invested $1,800 times by the rate, which we didn't know, times by the time, which is 18 months, which is 1.5 years. The order of multiplication doesn't matter, so I can work that out. 1,800 times by 1.5. So 141.75 is equal to 2,700 times by the rate. If I want the rate, I need to divide by 2,700, which is the opposite of timesing by 2,700. That cancels, so the rate is going to be 141.75 divided by 2,700, 0.0525. That is a decimal as a percentage. It is therefore 5.25% per annum is the interest rate. Sven sells his house, deposits the proceeds, 124,000 deposited. For 1 year, the account pays 8.4% compounding monthly. How much interest will be earned? So you could use the compound interest formula, FV is equal to PV times by 1 plus I over K to the power of Kn. But what did I tell you in the lessons is you should use TVM solver for anything compounding interest. So in this situation, interest rate is 8.4 PV. He deposited 124,000, so in TVM solver you're going to put negative 124,000. He didn't make any extra payments regularly, so payment PMT is 0. FV is what I'm solving for because I want to know what it grew to. PY and CY at year 11 are the same, and it was compounding monthly, so PY and CY happening 12 times a year. And now I can work out what N is. N is 1 year, and it compounded 12 times a year, so N is going to be 12. So if I put that into TVM solver, 12, 8.4, negative 124,000, 0 payments, PY and CY both 12, solve for FV, I get 134,826.52 rounded to 2 decimal points, which is what it grows to, but the interest is what it grew to, 134,826.52 minus what I put in, 124,000. So the interest, 134,826.52 minus 124,000. That comes to 10,826.52 in interest earned over that period. When you retire in 25 years' time, you want to have 50 grand to throw a big party. 25 years is important. 50 grand is important. Bank is currently paying 4.9% interest. Compounding annually is important. How much do I need to deposit in my bank now? You could use the compound interest formula, but as soon as it's compounding, use TVM solver. So N, the interest rate is 4%. PV, it's asking me how much do I need to deposit now, so it's asking for PV to be worked out. PMT, nothing at year 11 level. FV, you want to have 50 grand to throw a big party, so that's what you want your account to grow to, 50,000. PY and CY are both the same at year 11, and it's compounding annually, so PY and CY should be 1. When you retire in 25 years' time, so if something is happening once a year, and it's happening in 25 years' time, N will be 25 times by 1, which is 25. So I chuck that into TVM solver, 25, 4, PMT nothing, FV is 50,000, PY and CY are both 1, solve for PV. That tells me it's negative 18755.84 to 2 decimal points. Therefore, must deposit $18,755.84 now. Okay, page 1 done. Page 2. Ahmad receives $45,000 superannuation payment. He checks a number of banks and finds the following rates: 7.5% compounding quarterly, 7.25% compounding monthly. Compare the interest that would be received over a 10-year period from these banks. They're both compounding, so we're going to do 2 TVM solvers. Bank Y, N, leave that for now. Interest rate is 7.5%, so 7.5. PV, he's depositing 45,000, so negative 45,000. No PMT at year 11 level. FV is what I'm solving for. PY and CY, compounding quarterly, so 4 quarters in a year. So that allows me to work out N, because 10 years times by 4 times a year is 40 periods. So in TVM solver, 40, 7.5, negative 45 grand. Make PY and CY both 4, solve for FV. FV is 94,605.72 to 2 decimal points. So how much interest is that? Interest is equal to 94,605.72 minus the 45 grand I put in. 94,605.72 minus 45,000. 49,605.72. Interest for Bank Y, Bank Z, N. Don't know that yet. Interest rate is 7.25, so 7.25. PV was still the 45,000. No PMT. FV is what I'm solving for. PY CY. Compounding monthly, so both are 12. 10 years, 12 times a year, so 10 times by 12 is 120 periods. In TVM solver, 120, 7.25. Change PY and CY both to 12. Solve for FV, 92,710.45, rounded to 2 decimal points. Interest, 92,710.45 minus what I put in the first place, 45,000. 92,710.45, take away 45 grand. 47,710.45. Compare the interest that we received. We just found those in which bank. So therefore, deposit in bank Y. Why? Because he gets more. 49,605.72 versus 47,710.45. Annualize the following interest rates. So annualize or effective rate, you're using the EFF function on your calculator or the online annualized interest rate calculator. So A, in EFF, I put in the nominal rate, which is 3.9, comma, compounding monthly, so how many times is it compounding a year? 12. So that's what I put into EFF, 3.9, comma, 12. That tells me it's 3.97% per annum, rounded to 2 decimal points. The effective rate, B, EFF, put in the nominal rate of 14.8, compounding half yearly. How many half years are there in a year? 2. Apps Finance, scroll to EFF, 14.8, comma, 2, gives you 15.35% per annum, rounded to 2 decimal points. So that's effective or annualized interest rates. If you got a graphics calculator or the graphics calculator app on your computer works, you could use that. If you don't, then you use the little app that I've linked on Daymap. Savings account pays 3.1% per annum interest. Calculate the interest earned for the month of April given the transactions listed in the table. So as it said in the lessons, you have to do an interest calculation for each different balance. There are 3 different balances here, so you're going to have 3 calculations. So 1st April to, when does it change? It changed on the 9th. So I've got 950 from the 1st to the 8th. How many days is this? That is 8 days. So SI is equal to the amount in the account, 950, times by the interest rate, 0.031, times by the time in years. But 8 days is not a whole year, so it's a fraction over 365. So on your calculator, be careful with BEDMAS. You get 8 divided by 365 first, then times it by 0.031, then you times it by 950, and that gives me 0.65 rounded to 2 decimal points, so 65 cents. Now we've got 9 April 2. It changes on the 20th. I withdrew something on the 20th. So it's at 24.50 from the 9th up to the 19th of April. 9 to the 19th, 9. So including the first day, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That counts 11 days. If you're wondering what that sound was, I'm literally recording this video with my iPad sitting on a keyboard. So it's a bit awkward for me, but I figured I'd be able to do it really quickly. All right, so 24.50 is the amount in the account, times by 0.031, times by the number of days, 11 on 365. Calculated time, 11 divided by 365 is a decimal, times by 0.031, times by 24.50. I get $2.29, rounded to 2 decimal points. And then we have the last bit of April, because we want to know what happened in April. How many days in April? January, February, March, April, May, January, February, March, April, May. April is between two knuckles, so it must be 30 days. So the 20th of... iPad almost fell. 20th April to 30th of April. Count with your fingers. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I get 11 days again. SI is equal to... how much was in the account? 1900 times by the rate of 0.031 times by 11 days out of 365. 11 divided by 365 times by 0.031 times by 1900. I get $1.78 rounded to 2 decimal points. So how much interest earned in April? 0.65 plus 2.29 plus 1.78 equals 65 plus 29 plus 1.78. We get $4.72. Last one. Maurice's income. He was 74 grand. He receives a $6,900 return on investment. Find how much tax Maurice will pay on the investment. So you need the tax table from book. Tax table from book. If he's earned an income of $74,000 plus the $6,900, 74,000 plus 6,900, you get 80,900 in income. And if you chuck that into the table, you see that it's a 37% tax rate. So how much tax will he pay on the investment? Tax equals amount times tax rate as a decimal. So it's going to be 6,900 times by 0.37. 6,900 times 0.37, 2553. B, what's his after-tax return investment? ATR. He was supposed to get $6,900, but the government took 2553. 6,900 take 2553. He got 4347. Last one. On May 1st, Peter obtains a $15,000 line of credit at 4.8% per annum interest. Withdraws $4,000 on May 3rd. Another $7 grand on May 10th. Calculate the interest he must pay in May. So, let's deal with all of May. May is January, February, March, April, May. May is 31 days. Check with your knuckles. So every time there's a different amount, just give me a sec, I've got a student coming in. Can I just finish this recording? So just record. I'm recording a video for you. It's a maths lesson. It'll be good so that these guys can realize it's being done live. So just chill for now. All right, so on May 1st, he opened a line of credit and he only withdrew something on May 2nd. So May 1 to May 2, which is 2 days. 0 interest because he hadn't withdrawn anything. But May 3rd, 2. He withdrew another 7 grand on May 10th. So it's 4 grand withdrawn from May 3rd to May 9. So May 3, 4, 5, 6, 7, 8, 9. That's 7 days. SI is equal to how much have we drawn? 4 grand. Times by the interest rate as a decimal, 0.048. Times by the number of days, which is 7 over 365. I'll erase that. 365. 7 divided by 365 times by 0.048 times by 4 grand. He's going to pay $3.68 interest to 2 decimal points. And then we have the rest of May. So May 10 to 31st, May 31st, I'll be consistent, May 31. How many days is that? 22 days. SI equals, he withdrawn $4,000 and withdrew another $7,000 on May 10th. So that is $11,000 in total. Remember, with a line of credit, you're working out interest on what's been withdrawn. So 22 over 365. Calculator, 22 divided by 365. Times that by 0.048. Times that by 11,000. I get $31.82, rounded to 2 decimal points. So the interest in May, $31.82 plus $3.68 equals $35.50 interest in May. I think that's all the questions. All right, that's the video done. I'll see you in the next one.